Out in the middle of the ocean, you can sometimes spot a gigantic steel structure standing alone against the waves. From a distance, it looks like a floating industrial city, but it exists for one purpose only: to extract oil from deep beneath the sea floor. That sounds simple, but the oil is not sitting just below the surface. It lies kilometers beneath the ocean floor, buried under ancient layers of rock. That means an offshore rig does not just drill through seawater. It must continue drilling several more kilometers into the earth itself. Some offshore wells have a total length of more than 10 kilometers, making this one of the most complex drilling operations humans have ever attempted. To make that possible, the rig has to remain stable in deep water, high waves, strong winds, and shifting ocean currents. Some platforms use massive steel legs anchored directly into the seabed. Others float entirely on the surface and are kept in place by huge mooring systems or highly precise positioning technology. Because at these depths, even a small deviation can mean failure. Everything has to be controlled with extraordinary accuracy. But before the drill bit ever starts turning, there is an even bigger question to answer. Where exactly is the oil? Offshore oil does not exist as giant underground black lakes. It is usually trapped inside porous rock layers deep below the seabed. To understand that, we have to go back tens of millions of years. When tiny marine organisms and plankton died, their remains settled on the seafloor and became buried under layers of mud. Over immense spans of time, heat and pressure transformed that organic material into oil and natural gas. But once oil forms, it does not necessarily stay where it was created. Because it is lighter than the salty water underground, it tends to migrate upward through tiny spaces in the rock. If nothing blocks it, it keeps moving. An oil reservoir only forms when the oil encounters two critical conditions: a porous rock layer that can store it, and a sealing rock layer above it that prevents it from escaping further. The porous rock acts like a giant sponge, while the sealing layer acts like a lid, trapping oil over millions of years. That is why not every part of the ocean floor contains oil. Companies have to find the right geological structures that can hold it. These might be ancient folds, salt domes, or faulted rock layers that later became sealed. From above, the seafloor may look flat and empty, but far below, it is a complex geological maze. To map that invisible world, geologists use seismic technology. They send sound waves down into the earth and analyze the reflected signals that come back. From those faint echoes, they build a picture of where the reservoir rock, sealing rock, and possible oil trap may be located. Only when that underground map becomes clear enough does an offshore rig finally appear, aiming at a tiny target hidden beneath kilometers of water and rock. Once the location is confirmed, drilling can begin. But what goes down first is not just a single steel bit. It is an entire drill string made of connected sections of pipe. At the very bottom is the drill bit itself, the component that crushes through rock. Modern drill bits do not cut like knives. They grind and break rock using extremely hard materials, sometimes including industrial diamonds. As the well goes deeper, the rock gets harder, the temperatures rise, friction increases, and pressure becomes more dangerous. That is why rigs pump down something absolutely essential: drilling mud. This fluid travels down through the drill pipe, exits at the bit, and carries crushed rock fragments back up to the surface. It cools the bit, lubricates the system, and helps control the pressure inside the well. Without that pressure control, oil or gas could surge back up the well in one of the most dangerous accidents in the industry. As drilling continues, the walls of the well have to be reinforced with large steel casings that are cemented into place. This prevents the well from collapsing, reduces leakage between rock layers, and makes the entire structure much safer. In reality, an offshore well is not just one open hole. It is a series of steel layers nested inside one another, getting smaller as the well goes deeper. And the well does not always go straight down. With directional drilling, engineers can bend the well toward the richest part of the reservoir. That allows a single offshore platform to reach multiple targets without building multiple rigs. But reaching the oil reservoir does not mean the oil will immediately flow to the surface. Once the drill enters the producing zone, the well has to be completed and turned into a safe production system. Engineers run production tubing into the well to create a controlled path for oil and gas to travel upward. Then they use special tools to perforate the casing and cement at the right depth, opening small channels that allow oil and gas to enter the well. If the natural pressure in the reservoir is still high, the oil may rise on its own. That is the ideal situation because it requires less support. But as pressure declines, operators often have to use artificial lift systems, such as gas lift or electric pumps placed deep in the well, to bring the oil up. And what comes out is not clean oil. It is usually a mixture of oil, gas, salt water, and other impurities. From there, the oil begins another journey beneath the sea. Many offshore fields do not rely on just one well. They use entire subsea networks connecting multiple wells together. At each wellhead, there is often a special steel assembly called a subsea tree, sometimes nicknamed a Christmas tree. It controls flow, regulates pressure, and can shut in the well if something goes wrong. Oil from multiple wells is then directed to subsea manifolds before entering long underwater pipelines that can stretch for dozens of kilometers. These pipelines must withstand high pressure, resist corrosion, and maintain enough heat to keep the fluids moving. If the oil cools too quickly in the cold, deep ocean, waxes and hydrates can form and clog the entire system. That is why many pipelines are insulated, heated, or treated with chemicals to keep flow stable. In deep water fields, humans cannot simply dive down and fix the equipment by hand. Aid Kaje, no, that work belongs to remotely operated robots. These machines function in darkness, freezing temperatures, and crushing pressure. They inspect valves, connect pipes, and help maintain the steel city hidden beneath the surface. Once the production mixture reaches the rig, processing begins. The fluid coming up is not pure oil, so it has to be separated from gas, water, and contaminants. Inside large separator vessels, pressure and temperature are carefully controlled, so the components gradually separate into layers. Gas rises to the top, stabilized oil remains in the middle, and water and heavier materials settle at the bottom. The gas that is separated is not always wasted. It can be used as fuel to run turbines and generate electricity for the rig, or it can be compressed and transported as a valuable product of its own. The separated water also cannot simply be dumped. It has to be treated carefully, and in many fields, it is even pumped back underground to help maintain reservoir pressure. The oil, once stabilized and measured, is then sent either into export pipelines or to floating storage vessels. From the outside, an offshore rig may look like a lonely steel structure in the sea, but inside, it is really a floating factory where raw fluids from deep underground are transformed into something stable and safe enough to leave the ocean. And yet offshore drilling is not just an engineering triumph. It is also one of the most dangerous jobs in the world. People work here surrounded by heavy machinery, high winds, rough seas, corrosive salt, and highly flammable fluids under enormous pressure. Even the environment itself is hostile. Decks can become slippery, storms can arrive quickly, and the distance from shore makes every rescue harder. But the greatest danger is often invisible. It is the pressure trapped beneath the seabed. If control is lost, oil or gas can erupt back up the well with extreme force in a catastrophe known as a blowout. This is the nightmare scenario of offshore drilling because in just minutes, an entire operation can spiral out of control. That is why offshore rigs are protected by multiple layers of safety. Gas sensors, emergency shutdown valves, fire suppression systems, strict procedures, and most importantly, the blowout preventer. A massive safety device designed to seal the well if everything goes wrong. But even the best technology cannot eliminate risk completely. Offshore, every mistake becomes more serious, more dangerous, and far harder to fix. And that may be the most important truth about offshore oil rigs. To bring oil from deep beneath the ocean floor to the surface, humans must do far more than master engineering. They must confront darkness, pressure, distance, and danger head-on.